In this example, I'm going to go ahead and graph this system of linear inequalities. So the first thing I notice about both of these is they're in standard form, and in order to maybe graph them a little more easily and decide where we're going to shade, let's go ahead and put both of them in slope-intercept form, which means I'm going to solve for y for both of them. Okay, so the first one is x plus y is greater than 5. So to solve for y, I'm going to subtract x from both sides. So y is greater than negative x plus 5. Now to effectively graph this, I need 4 pieces of information, and the first two will be the slope and the y-intercept. So since we are in slope-intercept form, my slope is going to be the coefficient of my x, so it's a negative 1 or negative 1 over 1 in terms of rise over run. And b is going to be my y-intercept, so that's 5. This is going to be a dashed line because the inequality is y is greater than, but not equal to. So it's going to be a dashed line because the boundary itself is not included in the solution set. And then it's y is greater than, so I'm going to be shading above the line. Okay, so let's look at the next one. X minus y is greater than 1. So to solve for y, I'm going to subtract x from both sides. Negative y is greater than negative x plus 1. But I don't like this negative y, so I'm going to divide every single term by negative 1. And I get y is, and I have to switch the sign of the inequality whenever I divide by a negative. So x minus 1. So same thing as before, I need 4 pieces of information. So 1 is the slope, which is going to be 1 or 1 over 1 in terms of rise over run. And my y-intercept is negative 1. And this is y is less than, so I know we're going to have a dashed line, which indicates the boundary is not included in the solution set. And since it's y is less than, I know I'm going to shade ultimately below that line. Okay, let's go ahead and graph this. We'll start with this one. So our y-intercept is 5, so we're going to put a 5 right here on the y-axis. Our slope is negative 1, so it's down 1 over 1, down 1 over 1, and this is going to create for us a nice downward slope. And we can even put 1 back up here if we want to. And this is going to be a dashed line when we graph it. So our other one is this one down here. So we're going to start at negative 1, and we have a slope that's positive 1. So up 1 over 1 this way. That's the duplicate point up there. We can also come back down here as well and kind of continue this line. And this one as well will be a dashed line. So let's go ahead and grab our handy dandy straight edge. And we're going to go ahead and graph both of these dashed lines. Okay, and then the other one. Okay, so both of my lines here are dashed lines. So now I need to decide which of these 4 regions are we going to shade. Well, for our first line, y is greater than negative x plus 5. I know I'm going to shade above, so I'm either going to shade in this region or this region. And my other one is y is less than, so here's my x minus 1, so I'm going to shade below, which means either this region or this region. So it appears like here is my duplicate region, so here's where they overlap, which means this region is a solution set to both inequalities simultaneously, so that's where I'll shade. And this right here is the graph for this system of linear inequalities.